Today, we're diving into the RFID module to explore how it works and what it can do. First, we'll walk through the basic functionalities of the module. Then we'll explore how to integrate it into our projects to read information from an RFID tag. So without waiting, let's begin. This is the popular and affordable RFID module, used in various DIY electronics projects for wireless identification and tracking. This module consists of 8 pins, which I will explain each one fast. The first pin is SDA. This pin is used by the microcontroller to select the RFID module when communicating with it. The second pin is SCK, providing the clock signal for SPI communication. The next pin is MOSI, used for sending data from the microcontroller to the RFID module. Next is MISO, used for sending data from the module back to the microcontroller. The other pin is IRQ, which can be used to signal the microcontroller when certain events occur, for example, when a tag is detected. Next pin is RST, used to reset the module. And the last 2 pins are GND and VCC for power and ground. Keep in mind that this module uses 3.3 volt, so using higher voltages might destroy your module. Now let's see how we can use this module to read some tags infos. The components that we need for this project are a microcontroller, the module, some wires, and the RFID tags. You can pause the video and connect the wires as shown in the figure. Keep in mind that assembling this module on a breadboard may cause it to malfunction or not work properly. So wire up directly to module. Our next step is to program the microcontroller. First, what you need to do is to download the necessary library. The library that we are going to use is MFRC 522 by GitHub Community. Once we've added this library to the Arduino IDE, we'll explore some of the examples it provides. Navigate to the file and from there go to examples. Here, we can see that the new library has been added, offering a variety of examples for us to use. For this video, we will use the dump info to read the information from a tag. Connect your Arduino, upload the code, and you're all set. Also, open the serial monitor to be able to see the information on the screen. You can see that each tag has its unique UID and can also store up to 1 kilobyte of information. The informations that are printed on the screen are the memory blocks of the tag, and since we haven't write anything to it yet, they are all empty. You can try this module by any tags or RFID cards that you have. In the next video, we'll dive into creating a custom ID detection system using the RFID module. Make sure to subscribe so you don't miss out on this and other exciting upcoming tutorials.